Welcome back. Session 3, Part 2. In this session, I would like to take a walk with you and give you quite a number of examples where we are going to establish hypotheses. Basically, a data scientist is supposed to ask the proper questions, to look at the proper parameters and variables, and to put a perspective in the process so that the exploration is going to be meaningful. Let me begin with an example on my screen. Here is a case. A teenager, 18 years old, and is allowed to have the driving license and going for a driving school, and hopefully by the legal age, he or she is going to obtain a driving license. The common sense, after many years, many decades of teenagers applying to get the driving license, is that if you're 18 years old, you have a driving license in front, okay? So that's the common sense. That is understood as the golden rule. If by any reason, by any scenario, you decide not to take the driving license while you are 18 years old, your parents as well ask why. That seemed to be a little bit out of place, maybe a kind of an anomaly, and they would like to see what's the reason behind you not taking the driving license, especially since the sooner you get the driving license, the more you build on the history of your insurance, bringing down the cost of monthly insurance costs, right? So let's make an assumption. Let's assume that in United States of America, we have 20 million children who are of the age of 18. So let's focus on that bracket, and the bracket is 18 years old. One way of examining this is to call and ask those 20 million people to let us know if they have applied or obtained a driving license while they are in the age bracket of 18. This is not going to be possible. It's extremely difficult. And by the way, why do you want to do that anyway? Excuse me. So in order for us to understand the statement and see whether the statement actually applies as a golden rule, what we are going to do is this. We are going to go into, we are going to actually take samples. We are going to have 2,000 calls made. Once we are going to make that, we are going to ask the teenagers, did they apply or obtain driving license? There is going to be yes, 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 and no. Then there is going to be another sample, again 2,000, with the same distribution, random distribution that we have applied in the first sample, and we are going to call them and ask them, and they say yes, 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 no, 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 yes, 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 yes. When we aggregate the results, we see that the first sample, 1,950 teenagers have applied or obtained driving license. In the second sample, I see 1,936 teenagers have obtained driving license or applied for. I'm going to scratch my head and I'm going to say 1,950 in one sample, 1,936 in another sample. Yes, yes, there are people who are not applying for driving license for many reasons, but the first sample, 50 people didn't apply or obtain. And that's the second sample, 64 people didn't apply or obtain. So when I take a look at these two samples, 2,000 only, not 20 million, I see that there is no significant difference between these two samples. This is why we call our original statement a null hypothesis, null, N-U-L-L. It is empty. That's what it means. There is no significant difference between sample A and sample B in terms of the outcome. There are some minor differences, but I'm sure if you have another 2,000, you might as well have a different outcome, in a sense that perhaps 1,958 teenagers achieved a driving license or applied for. You see, those variations are going to be extremely small, insignificant. That's why we say no significant perturbation exists, no significant change exists in the two samples. And we are going to declare the statement that teenagers of 18 years old apply or obtain driving license. What is the alternative? The alternative is going to be teenagers of 18 years old do not apply or do not obtain a driving license. These two are supposed to be mutually exclusive. So what do I have? I have a null hypothesis and I have a alternative hypothesis. In this case, the null hypothesis is the accumulation of so many years of observations of parents themselves applying and getting the driving license at the age of 18, and also observing their teenagers to apply and get the driving license. And it has happened perhaps more than 70 years of car industry in existence, and it goes all the way to 1920 and 1910 and so on. So when we talk about this, still I want to elaborate one very important aspect of this observation. The observation is that I need you to take a look at the variables that are involved. The first variable that you need to keep in mind is the age of that person. And the second variable is the driving license, yes or no. Did you get it or not? Now, one of them at least is an independent variable. And in this case is the age that is called independent variable, and the outcome, the output is going to be a driving license. So there is an input and there is an output. Input and output. When we talk about input and output, then you are going to identify what the input variable is and what the output variable is, outcome is, and you're going to call the variables appropriately. In this case, age is going to be independent and driving license is going to be dependent variable. Now, you might say, why don't we reverse this statement or this allocation of variable? Let's ask this question. If driving license is considered to be independent variable, can you go back and immediately conclude that the person is 18 years old? No. The person could be 50 years old, 45 years old, and so on. So that doesn't ring the bell. That doesn't seem to connect well in terms of a relationship between the variables of the observation. Another question, as a domain expert, you know, you need to always ask these questions. You could quickly exclude them, but you need to ask these questions. Does the gender of the person really relates to the outcome? No. It mainly depends on the government rules and regulations allowing the teenager to apply for the driving license. Make sense? If it was 1900, 1800, I'm going too far back, then the situation might be different because at that time the culture was different. But now in the past 3 decades, 4 decades, 5 decades, and the huge explosion of the population that we have in North America and elsewhere, we have enough data to conclude that the common sense is that 18 years old is going to have a driving license applied for or obtained. It has nothing to do with gender. Let's try another one. Does the weight of the teenager has an impact on the driving license obtaining or applying for? No, doesn't make sense. There is no reason for a person to be of different size to decide upon that whether to apply or obtain a driving license. There are other factors, for example, the vision. Yes, as part of the driving license procedure, you need to actually go through the vision. And without the vision test, obviously you're not allowed to come for the actual test, and you will not be given a driving test. So you need to have the vision tested first, right? So if there is anything that you need to do, maybe you have to go and obtain appropriate glass according to your eye vision. That's what it is. So that seems to be a factor. That could be a factor, right? You need to examine all of the variables and say, what is the independent variable and what is the dependent variable, and what can I control, what is it that I need to look into as an input, and what could be the output, which is going to be the outcome. Let's take a look at this example. Again, as you can see from the top of my menu, I have quite a few examples, and I want to explain them all because I hope by the end of this session, you already know how to create your own hypotheses and call them null or call them alternative hypotheses. These two are mutually exclusive. What does it mean? You can't have both of them correct at the same time. You can't. So take a look at this. I'm going to claim a simple statement, and the statement is that the eggs will harden in 3 minutes while in boiling water. So boiling water, 3 minutes, eggs hardened. This obviously, humanity has had chance to examine this perhaps for thousands of years. Observations upon observations have actually certified this conclusion in many ways. Now, you might say, okay, is this a null hypothesis? And what could be the alternative hypotheses? What are the variables that I need to look into? What is my input and output? You need to ask those questions before you actually establish the experiment in more detail. So the way you need to do is this. I'm not going to go and check all of the existing eggs on the planet Earth. That's impossible to do. And the way I'm going to do it is simple. I'm going to go to one store and pick up a dozen of eggs, and then I'm going to go to another store and pick up another dozen of eggs, and then I'm going to come in and basically, or maybe even ask the different people that I'm calling to say, okay, can you please do this experiment for me? And then what happens is that when you come back, you take a look at the two samples and you see apparently, except from one or two in one sample, one or two in another sample, apparently these two samples look a lot similar. All of the eggs almost, you can even add the word almost inside, all of the eggs have hardened in 3 minutes while they have been in the boiling water. So we call this null hypotheses. What does it mean? It means there is no significant difference between sample A and sample B. If I try and have different eggs, perhaps even try eggs in east of US versus eggs in west of US, there isn't much of a difference. And it has been like this with so many observations in the past. It's established rule. You might say, listen, I'm going to prove you wrong. I'm going to show you that there are eggs that are going to be, many eggs as a matter of fact, that are going to harden before 3 minutes or after 3 minutes. Not exactly 3 minutes, 5 minutes, 2 minutes. So you have your own experiment and to either basically prove it or disprove it. But the matter of the fact is it's very simple. These two samples that I just showed you apparently confirm the fact that the common sense says that the 3 minutes is the mark, the time mark, with the boiling water for 3 minutes though. So we are not talking about the water that is not boiling for 3 minutes and then hardening the eggs inside. Now, what are the variables? Well, there is one, time. There is another one, temperature, boiling water. There is another one, hardened egg. You also need to consider the size. Is the size an important factor? So we have, as you have gone to shopping stores, you can see that there are small eggs, medium-sized eggs, and large eggs, and extra large eggs. Would they matter? You could say yes, because if they are extra large, obviously the center of the eggs are going to be farther away from the shell of the egg, and therefore 3 minutes may not be enough. So you're going to actually add that to your observation and your statement as you move on to make your observation in a more complex environment. Does the color of the egg matter? No. Egg could be white, it could be brown, or a different color. So the color really doesn't matter, right? So you need, when we talk about experiment, you really need to basically, first and foremost, is there a common sense? But it's not going to be like that all the time. As a data scientist, you're going to be facing challenges and opportunities as you move into your life that you haven't seen before. And maybe there are cases that are not studied or observed by others in the past centuries, decades, or thousands of years. And those unknown territory, you need to come up with a proper question to ask, proper statement to make. Let me try another one, and then maybe it's enough for this part, and I'm going to continue my my links in the follow-up recordings. This is a case of a stock market. The stock market, as you know, is spoken of to become a random signal, to be considered as a random signal. And your question is simple. Your question is, for a very specific stock, perhaps is a person having access to the insider information or not? Is he or she playing fair in the stock market? So what you are going to do, you are going to actually grab two different sets of investors, and you are going to take a look at the outcome. Maybe one set is going to be retail investors or institutional investors, and then you are going to grab some of these institutional investors in one sample, and then some of the institutional investors in another sample, and you take a look at their performance in regard to Apple, for an example. And when you take a look at the performance, you see there is not much difference between the performance of this basket of institutional investors and this basket of institutional investors. You don't see much of a difference. When you say there is no significant difference between these two baskets, you immediately have a null hypothesis. The hypothesis is institutional investors do not play on market based on insider information. This is going to be tough to discuss, but at the same time, you haven't had a time to examine it. A stock market, the way we know it, is relatively new, a couple of decades old, and you may not have had enough time to observe all of the peculiarities of a stock market to make any other statement. So your observation has become limited, and therefore you're facing with something which would be considered unknown, but the question is asked, and you need to either prove it or disprove it. And if it is well established, then we call it, it's a kind of a golden rule. It's simple. It's not established, well established, then you're going to have what we call null hypotheses, and then you're going to create alternative hypotheses. The alternative hypothesis is institutional investors have access to the insider trading, and they have access, and therefore they are not playing fair. These two are mutually exclusive. Not both of them are going to happen at the same time. So please keep that in mind. With that, I would like to stop, and then I'm going to start my few other examples in a moment. Thank you. Stay tuned.